All right, today we're going to be talking about inverse functions. So inverse functions are functions that undo each other or functions that are opposite. So addition and subtraction, those are inverse of each other. So subtract. So a relation is a relationship between points. And that means like x, y. So x is related to y somehow. A function is when we have exactly one x with one y. So we can tell this by the vertical line test. If we use our pencil and trace and it hits one or more points at a time, remember it's not a function. Okay, so what we're going to do now is we're going to graph example 1 and example 2, and then we're going to compare. So example 1 is just a quadratic function, so it should look like a parabola. So if I start plugging in these numbers, I'm going to square them. So negative 3 squared is 9, negative 2 squared is 4, negative 1 squared is 1, 0 squared 0, 1 squared 1, 2 squared 4, and 3 squared 9. So then those become the points that I graph. Okay. Okay, so it does look like a parabola. We can find our domain and range. Domain, remember, is left to right, so it's negative infinity to infinity. Range is from bottom to top, so bottommost is 0. Topmost is infinity. Okay, so now it's going to ask us to graph two different functions on one graph. So we're going to use the top table as square root of x and bottom table as a negative square root of x. So square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and square root of 9 is 3. So that gives me that little arc. And then the bottom one, negative square root of 0 is 0, negative square root of 1 is negative 1, negative square root of 4 would give me negative 2, and negative square root of 9 would give me negative 3. So now, if we were to look at this graph as 1, we would see that this is literally plus or minus the square root of x. This top one is plus, this bottom one is minus. So together, they make the sideways version of our graph on the left. So our domain for this one is left to right, so our leftmost number is 0, and our rightmost number is infinity. Bottommost, well, this number is going forever down, so it's negative infinity. Topmost is positive infinity. So let's compare and contrast example 1 with example 2. Well, we already said that this first graph is a different version of this right graph. They are rotated, or they're just the same shape of the graph, just on different planes. We could also look at our domain and our range. Well, our domain here is the same as our range on the opposite one, and our domain on the example 2 is this exact same as our range on example 2. So our domain and our range flip. And remember, domain is x values and range is y values. So if our domain and our range flip, then our x's and y's must flip as well. So let's check that. So our x here is negative 2 through 3, or negative 3 through 3. Our y's here are negative 3 through 3. Well, our y values on the first one are 0, 1, 4, 9. Our x values on the first ones are all 0, 1, 4, 9. So our x's and our y's all switch, which is because our domain and our ranges switch. And our graph rotates. Okay, so inverse functions are functions that are opposites. So everything is opposite. Okay, so solving to find inverses. So there are 2 steps to solving to find inverses, and we are going to follow them every time. So the very first one is to switch our x's and y's. Our second one is to solve for y. Okay. So number 1, we're going to switch our x's and our y's. I could rewrite this as y equals x squared plus 2. So I'm literally going to replace x with y and y with x. And that's because, remember, our very main characteristic of inverses is that x's and y's change. So x equals y squared plus 2. So now I'm going to solve for y. So I'm going to subtract 2. So x minus 2 is equal to y squared. And now in order to get rid of that exponent, remember we have to square root. And remember that super important rule for square rooting. If we take the square root of something, we have to put plus minus. Okay, so I solved for y, I got y alone. Now, inverse notation is this f inverse of x. So f to the -1 of x is inverse notation. So then I'm left with this plus or minus the square root of x minus 2. And that's my inverse for my original f of x function. So now it asks me to graph. So something that's super important about graphing inverses is we always graph original function first. So our original function here is x squared plus 2. So that's what we're going to graph. And remember with quadratic functions, we can plug anything into a quadratic. So I'm going to plug in -2, -1, 0, 1, 2. So -2 squared, so remember this is x squared plus 2. So -2 squared is 4, plus 2 is 6. -1 squared is 1, plus 2 is 3. 0 squared is 0, plus 2 is 2. 1 squared is 1, plus 2 is 3. And 2 squared is 4, plus 2 is 6. Okay, so I've got this graph here. Looks like a parabola. Okay, main characteristic of inverses was that their x's and y's switch. So now when I go to graph my second graph, I don't actually have to plug anything into this square root of x minus 2. All I have to do is switch my x's and y's. So my new x's are 6, 3, 2, 3, 6. So those came from my original y's. And my new y's are -2, -1, 0, 1, 2. And those came from my x's. Okay, so 6, -2, 3, -1, 2, 0, 3, 1, 6, 2. And I'm left with this sideways parabola. So this parabola is sideways. So let's go back to what would happen when we would graph a square root. Like anytime we graph a square root, it just looks like this, right? It looks like that half arc. So the reason that we're getting a half arc on top and a half arc on bottom is because this is your plus and this is your minus, and they combine to give you an entire parabola. So that plus minus really is important when we're talking about finding the inverse function or finding the graph of inverse functions. So anytime we have a square root function, it looks like an arc, but because we started with a quadratic and we know quadratics look like parabolas, because we start with a parabola, we have to end with a parabola. So if our original is a parabola, then our inverse is also going to look like a parabola on our graph. Okay, so domain of our original is negative infinity to infinity. Our range is 2 to infinity. Our domain is 2 to infinity. And our range is negative infinity to infinity. So notice how our range and our domain switched, and our range and our domain switched again. Okay. All right, number 2. So originally this is y equals the square root of x minus 4. So remember this good point. We always have to graph our original first. So we're going to keep that in mind, but we are going to solve first. So we're going to switch our x's and our y's. And then we're going to add 4. So x plus 4 is equal to the square root of y. So now, in order to get y alone, we have to square. So I'm left with x plus 4 squared is equal to y. So that's my inverse. Remember, inverse notation would give us f inverse of x is equal to, and I'd leave it as x plus 4 squared. And I'd leave it like that because we're not actually going to have to graph that one. Okay, so we graph the original first. So original graph is a square root. Remember, square roots look like arcs. So whatever we start with is what we're going to end with. So if our original looks like an arc, then our inverse is also going to look like an arc. So go ahead and graph your original. So original is the square root of x minus 4. So if it's the square root of x, remember we have to pick very specific things to plug into our square root. So we're going to pick 0, 1, 4, 9 because it's a square root function. So square root of 0 is 0, minus 4 is negative 4. Square root of 1 is 1, minus 4 is negative 3. Square root of 4 is 2, minus 4 is negative 2. Square root of 9 is 3, minus 4 is negative 1. So we did look like an arc. So now our inverse should also look like an arc. So xy, we're just going to flip our x's and our y's. So negative 4, negative 3, negative 2, negative 1. And then 0, 1, 4, 9. So negative 4, 0, negative 3, 1, negative 2, 4, negative 1, 9. Okay. So here's our new graph, or our graph of our inverse here. So we can no longer say that our original graph just rotates, because a rotation is just this exact same shape, just rotated, like if I were to swing this shape around. Really what's happening is if I put a line here, if I were to fold my graph on that pin, I would see that my points match up. So really we're reflecting over this line, and this line is y equals x. Okay. So domain of our original is 0 to infinity. Range of our original is -4 to infinity. Okay, so the next one should be the exact opposite. So domain of our inverse is -4 to infinity, which is the opposite. Range of our inverse is 0 to infinity, which matches up. Okay, so why does a quadratic function's inverse have 2 square roots? Well, we talked about that plus minus being the main reason. So plus is that top half, minus is that bottom half, and they combine to give you a full parabola. So why does a square root function's inverse only have half of a, I'm going to say parabola here? So it's asking on example 2 here, why did our quadratic function, which should have looked like a parabola, why was it only half? So it's only half, remember, because our original dictates what happens to our inverse. So the original function restricts our inverse function. Okay.